This video is about the telescoping series test, and what you have to think about is like a captain on a ship's deck. He has one of those expandable telescopes. Well, what's nice about those is that they collapse. So there's a very fancy definition for the telescoping series here. It says if we have the series, and it's the sum from n equals 1 to infinity of b sub n minus b sub n minus 1, where the limit as n approaches infinity of b sub n equals L, then the series converges to the sum of S equals B sub 1 minus L. For our purposes, all we really care about is, does the series collapse? So if you look at this series, we have 1 minus 1/2. That would be our first term. Our next term is 1/2 minus 1/3. That would be the second term in the series. The next term is 1/3 minus 1/4, the third term, plus forever. So if you actually look at the terms, you have a negative 1/2 here and a positive 1/2 here. So those would cancel out. You have a negative 1/3 and a positive 1/3, so those would cancel out. A negative 1/4 in the next term would start with a positive 1/4, so those would cancel out. As long as this series keeps going on to infinity, you can see that it's actually going to collapse down to 1. So because it's collapsing down, we call it a telescoping series. Now if it can collapse to one term or just to a finite number of terms, like it could have 3 terms left and the rest went away. It could have 5 terms left and the rest went away. It could have 100 terms left. As long as the rest go away, then it's a telescoping series, and we would say that it converges. So it says if a series converges to a finite sum, then it converges by the telescoping series test. Now, they are generally fairly obvious to spot, because if you look here, you have 2 different series here. We could take the sum of each separately, and they are subtracted. But very often, this is your first clue. This is telescoping. And the way you're actually going to see it is write out a few terms. So this is when n equals 1, this is 1 over 2 times 1 is 2 plus 1 is 3, minus, and this is our very first term, 1/5. Now I'm going to increase my n by 1 to 2. So 2 times 2 plus 1 is 1/5, minus 2 times 2 is 4, plus 3 is 7, 1/7. And you should be really suspicious right now because the negative 1/5 and the positive 1/5 do cancel out. My next term, if this is a positive 1/7, that's probably as much as you ever need to know. So we're up to n equals 3. So 2 times 3 is 6 plus 1 is 7. There it is, 1/7. And then this will be minus 2 times 3 is 6 plus 3 is 1/9 plus dot dot dot. So my 1/7 cancel out, my 1/9 will cancel out, and what I care about is that this series converges by the telescoping series test. And all you really need to show is that the terms are actually canceling out. If they don't cancel out with the one right next to it, that's okay. Maybe it'll skip one and they'll cancel out in pairs. But as long as they are canceling out, then the series will converge by the telescoping series test.